All right, hi. Instruction pamphlet number 74, June 1964. 26L brake equipment with the 26C brake and the 26F control valve and arranged with safety control, overspeed control, dynamic interlocking and multiple unit control for locomotives. New York Air Brake Corporation, Newark Brake Company, 748 Starbuck Avenue, Watertown, New York 13601. The J1 relay valve. Alright, the J1 relay valve figure 3 has a high capacity diaphragm operated with a self-lapping relay valve consisting of an O-ring packed stem and double-seated rubber check valve. Its purpose is to supply the exhaust brake cylinder air pressure during brake applications and release. This relay valve is designed to develop the brake cylinder's pressure approximately equivalently to the develop in the control pipe leading to it. This shows you the legend. 6 is the supply line, 30 is the delivery of the BC, and the 16 is the control. As you can see, it's seated. There's a spring here, valve through the supply and control valve with a diaphragm under the control valve, G1 relay valve. The operational portion is mounted on the pipe bracket to which all the pipe connections are made. This is identified as follows: number 6, the supply; number 16, the control; number 30, the delivery BC. During the brake applications, air pressure is developed in a line connection and the number 16 connection at the relay valve pipe bracket. The air pressure is developed into the chamber below the large relay valve diaphragm and piston, causing the diaphragm assembly and piston to move upwardly. During the upward piston movement, the end of the piston stem, which is formed with contains exhaust valve, the seat first contacts and seat against the underside of the rubber check valve to close the exhaust connection through the piston stem from the delivery brake cylinder or port from number 30. For other upward movement causes the rubber check valve to be moved off its supply valve and the main air reserve air is free to flow past the rubber checker valve at port number 30. The brake cylinder port number 30 is also connected through a stabilizing choke of the spring chamber on the interface with the relay valve diaphragm so that the pressure is being developed in the brake cylinders and equal pressure is being developed in the spring chamber. A diaphragm becomes balanced and is moved downwardly to a lat position with the rubber check is seated against the supply valve terminate the further flow of the airflow of the brake cylinder. The exhaust valve remains seated. The relay valve will function to maintain the delivery line of the brake cylinder pressure. Whenever the brake cylinder leakage should cause the brake to decrease, the pressure in the spring chamber will leak. Likewise, decrease in the diaphragm assembly in the piston stem will again be moved upward and highly controlled pressure against acting on its outer face. Thus, the rubber check valve will be forced off its supply valve seat, and the main air reserve will be free to flow from the brake cylinders to restore the pressure loss of the leakage. When equalization of the control pressure is reached, again, the piston and the diaphragm assembly will again move downward to a lap position, cutting off the further flow of the main reserve air to the brake cylinders. Upon the brake release, a reduction of the control air pressure acting on the outer face of the relay valve diaphragm will cause the higher brake cylinder pressure to move down the diaphragm assembly piston down toward where the exhaust valve seats will be drawn out of the seating contact with the rubber check valve. The brake cylinder air is then free to flow past the exhaust check valve seat through the piston stem of the exhaust port atmosphere. The graduated release of the brake cylinder air pressure may also be obtained whenever the control air pressure is intermediately released. Whenever it occurs, the high brake cylinder pressure causes the diaphragm to assemble to the operated with exhaust, but the diaphragm again becomes balanced, after which it will again assume to the lap position to close the exhaust. The M4 2A valve. The M4 2A valve, figure 4, is the three-piston cam-operated spool valve arranged with the pipe bracket. It is employed to enable the 26L equipment locomotive with the multiple unit with its own, not only 6 or 26 type equipment, but also with 24RL equipped locomotive. The 4U 2A valve pilots the F1 selector valve with the device that enables the equipment of a train locomotive to be controlled by the equipment of the lead locomotive in the multiple unit operation. Pipe connections are made to the pipe bracket as they follows: 2, the independent application of the release pipe from the BV; 3, the actuating pipe from the BV; 13, the actuating pipe; 20, the independent application release pipe; 30, the main reserve; 53, the multiple unit control pipe; and 63, the multiple unit interlocking pipe. 3 S-cons placed face are available for the use for this valve. Portion arrangement is not affected with the S-con plate employed. The markings on these 3 S-con plates are as follows. The 3-position black lettering lead or 3-position black lettering lead or dead trail 6 to 26, trail 24, or you have the 3-position red lettering lead or dead trail 6, trail 26 to 24, and 2-position black lettering lead or dead trailing 26 to 24. The position of the the MU2A valves are selected with the positioning of the handle. To do this, handle will be depressed over to come to some bring loading to the permit is being moved. The handle should be positioned when arrows pointing whenever the position is chosen. All right, operation.